Hello and welcome back to Purus Tech Java tutorials. In this session, we are going to talk about these points like thread priorities and the concept of locking, synchronized block, and the memory area of threads and thread join method. And this is how you can avoid the thread deadlock. This is one of the state where your program will halt and you will not able to recover from this situation. In the last session, we have talked about this 6 points. So let's just start from 7 point onwards in this particular session. Let's switch to IntelliJ IDEA here. And this particular example I had used in the last session also. So we'll talk about the thread priorities first. Let's say in your application, multiple threads you are creating and you want that a particular thread will be executed first or should be executed first. Then you have to give that thread to a maximum priority comparing to the others. So here I have created two threads, right? I can set the priority of this thread to be more and this thread to be less. So how do you set the priority? You need to set the priority before calling the start method. So my thread, just use the instance variable dot set priority, then thread dot. See, there are three variables here: max priority, min priority, and normal priority. Let's say you want to give max priority to this thread, or if you want to give min priority, then you need to say min priority. This is the normal priority, which is the default one. If you don't give any priority, this is the default value 5. So let's just give this one as a minimum priority, and this particular thread, let's give a max priority. Thread dot max priority. Let's just start the program and see what happens. As you see here in the console, the first statement in the main method, this has printed, and then what is the current thread name? That is the main thread, and then it has gone to the runnable interface thread. So here if you see thread using runnable, here my thread using runnable interface, so my thread using runnable interface. Since I had given the max priority to this particular thread, this has been taken first, and this will be taken second by the thread scheduler. Again, one more thing we need to remember, that this case we cannot guarantee that the max priority thread will be run first. So nothing is guaranteed in thread session or section of Java, because if the thread scheduler will take the max priority threads first, then the low priority threads will get idle and they will be starved. They won't get any job to be run. So that is why sometimes the thread scheduler will not guarantee that whatever max priority you have given, that will run first. Now let's see the concept of locking and the synchronization. So this particular synchronization is related to the resource or the memory area which is shared between multiple threads. Let me just open one example, the synchronization example. So here in this synchronization example, this class is implementing the runnable interface, and here is the logic for the thread. So counter utility, it uses a counter utility class which is defined here in the same file, and there is a counter here, and in this counter utility class there is one more method which is the increase counter, which increases this particular counter one by one. So multiple thread running an application is giving us some of the advantage. Also it has some disadvantage. If you are not writing proper code using the threads. And that particular situation comes when multiple thread access the same resource or the memory area. For example, here the resource I'm saying is the counter. This is a variable which is used by multiple threads to increase this particular count. If you see here in the main method, I have created multiple threads to run this particular logic. So all these threads will be using the same counter utility to increase the counter variable. So this resource or the class or the instance is being shared between all these threads. Let's say if you will not use this particular synchronized block, then what will happen? Let's see, we are just creating the counter utility object and we are saying increase counter. So these threads are going to increase this counter. What we expect from this logic is it will print the current value as 1, then 2, then 3, like that it should go on. But what will happen, we'll see in this program. See here the output. These 6 threads are calling this particular increase counter. So all these threads are trying to increase the counter one after another, or they expect the count to be like 1, 2, 3, 4, 5, 6. But main thing is you are not achieving the whatever you are expecting. What is happening is this counter is being shared between the multiple threads. So if you want a resource to be shared among the threads, then you should use the synchronization so that one thread should use that particular resource and after that only another thread should use that particular resource. It is not like at one shot every thread will use that resource. So you have to use the synchronization in these scenarios. So how many ways you can synchronize so that sequentially you will get the output? You can synchronize this method. So let's just first synchronize this method and let's see the output. And you will get the output whatever you are expecting. The current value is 1, 2, 3, 4, 5, 6. So what is happening once this thread 0, even I can set a name here for this particular thread, right? I can set any name so that this name will appear here instead of thread 0, thread 1. You can do that by your own. So once, let's say for example, the thread scheduler picks up thread 1 and it tries to run this particular method, which is there inside the run method. When it has entered to this particular method, it will acquire a lock on this counter utility object, which is a shared resource. So if it acquires a lock on this counter utility, no other threads can enter inside this method itself. So we are making a guarantee that no other threads will enter here unless and until thread 0 finished its work. So that is why first it has increased the value, counter value to 1, and once it finished, then only other thread, that is thread 1, is entering to this particular method and it is completing its task. Likewise, sequentially they are executing. So this kind of section is called critical section, where multiple threads are trying to use your common resource and they are fighting with each other who will run that particular method first. So there is a race condition arises whenever multiple thread access the same resource or memory area in a critical section. So this is what it means. So this is a critical section and there is a race condition. That is why we had used the synchronized keyword here at the method level. So if you are synchronizing a method, then the thread acquires a lock at the object level. If it is a static method, then it will acquire the lock at the class level. Now let's assume that you have a method and only few of the lines are in critical section. Then you should not synchronize entire method because this will delay your processing. You can synchronize a block of code using the synchronize block like this instead of the synchronize method. So this is very much useful when these lines, let's say 46, 47 and 48 lines, there are some logic which does not access any of the shared resource or shared variable. So here counter is a shared variable which is only used in this lines. So this can be accessed by multiple threads. Whenever one thread enters into this block, this will get locked by that particular thread. So this is at the block level, synchronized block. We covered the synchronize keyword and we covered at the block level. We covered at the instance level. Now let's talk about class level lock. So if this particular method is a static method and you want to lock this particular block, then you cannot use this keyword here. Instead, you can say counter utility dot class. This has to be a static variable. So you are acquiring the lock at the class level. So this is called the class level locking. Let's just revert it back. So we covered these things. Now let's talk about the memory area of threads. So each and every thread runs in its own stack. So we know that there are two sections in the JVM, that memory area. One is stack and one is heap. Heap contains only the created objects inside the JVM, and the stack contains the local variable and the reference variable of the method which we are using. So each thread will have its own memory stack on which they operate. Now let's talk about thread join method. So here I will just take an example of joining method example, and here is the code. Here what I have used, I have just created two threads, join method example T1 and join method example T2, and then I'm just starting the thread. So what this thread does is, and here in the run method you will see it is just printing the thread name, and there is a loop where it will sleep for 500 milliseconds. This is just for mimicking some jobs to be running here, and here it is printing the I variable here and then the thread name. Let's not use this join method, then I will come to the join method later, and let's run this program and see what output it comes. You will see here statement after calling T1 start. So here statement after calling T1 start, this is getting printed, but before to that it has just invoked the start method. So that means this thread has been given to the thread scheduler to start it. And after that, this particular thread has been given to the thread scheduler to start it. We don't know which thread will start first. That depends on the thread scheduler. So here it has started thread 1 and thread 2, and then again thread 1, thread 2 it is printing. So at one shot or concurrently it is running both the threads. Let's say for example we want something like after the thread 1 ends then only thread 2 start. Let's say this T2 is processing some data which is dependent on the thread T1. So what you should do is you can wait for the T1 to end, and after that only you should start this thread T2. So here you can use the join method. Join method will say that this main thread will wait for the T1 to complete here. So T1 will complete, then only the main thread will execute whatever statement there after this. So here let's just run it and see. So thread 1, it has invoked. So thread 1 has completed its job here statement after calling T1 start. So here you will see the thread T2 is starting only after thread 1 has done its job. So this is the work of this join method. Just to repeat, T1.join means the current thread. Which is the current thread? Current thread is main thread because this code is running in the main thread. So the current thread will wait for the T1 to finish. Now let's come to the thread deadlock and how to avoid this deadlock. Here I have an example of thread deadlock. Let's just rename it to thread deadlock example. So I can refactor, rename, and then say example. Okay, so thread deadlock example. Let's just open one diagram. Okay, so let's understand what is deadlock. Deadlock means your program or your application will halt over there and it will never come out. So when does this happen? Let's see. For example, there are two friends, Santosh and Harish, and they wanted to print some documents using two printers. One is HP printer, one is Epson printer. So this guy also, Harish also wants the printout from the HP printer and from the Epson printer. Let's say first Santosh went to the HP printer and then he started printing some document. Once he finished, he goes for the Epson printer. Just assume that beside to the HP printer, Epson printer is there, and Santosh has blocked this HP printer. He's saying that I will not leave this HP printer until and unless I finish both the work. So he blocked this HP printer, and then once he finished this one, he is not releasing this HP printer to, or he is not allowing anyone to take print from this HP printer. But he went to the Epson printer and he's trying to print. So when Santosh is using the HP printer, the same time Harish is printing something in the Epson printer. So they can do their own job separately by using HP and by using this Epson printer. Let's say once Harish has finished the Epson printer work, he wants to take some printout from the HP printer, which is again blocked by Santosh. So what you see here is Santosh is trying to get the Epson printer here, which is blocked by Harish here, and Harish is trying to get the HP printer, which is blocked by HP printer. So nobody is leaving the printer and they are trying to print. So how the work will happen? And here only the deadlock comes. So deadlock comes when your threads, one thread will wait for the lock which is held by another thread, and the second thread, that means another thread means that the second thread is waiting for the lock which is held by the first thread. So this is the situation where deadlock happens. Now let's see this situation in the form of program, the thread deadlock example. And as I mentioned, there are two printers, HP printer and Epson printer. So these are the resource, and this resource have the name, and there is some logic to print. So to just illustrate here, I have given a sleep for the sleep method for 10 seconds so that in the 10 seconds the printout will happen. Now this same printer class we have taken here and two objects we have created. One is HP printer object and one is for absent printer object. Now there are two users, printer user. So this printer user are nothing but threads. You can think of printer user. We have created two printer users. One is Santosh and one is Harish, right? Santosh and Harish, which I had explained it here. Now, Santosh user is created and Harish also user is created. Now they wanted to print. So here I'm saying just start. So what is there in run method? Let's see printer user dot run. In this run method, what it is doing is they are going to use the printer and they are trying to print something. So both will go and use the printer. They will try to print something and then finally they will come out of this run method. So let's go back to the printer user. Here, when I say printer user dot start, Santosh went and started printing paper. When I say printer user to 2.start, then Harish went and started using the printer. Now we have to see here how we have passed the printer. So printer user has two printers, that is printer 1 and printer 2. So in case of Santosh, I have passed the printer 1 first, that is the HP printer. So this printer 1 will be used first and then printer 2, that is the absent printer. In case of Harish, I have passed the printer 1, which is nothing but, so here printer 2, this is the situation where deadlock will happen. So here I have passed printer 2, the absent printer. So Harish will start using the absent printer first and then HP printer. Now what will happen is if you run this program, deadlock will happen. Let's see the output. As you can see here, Santosh is going to use HP printer. Then Santosh is using the HP printer. Santosh printing paper. Santosh printing paper using the HP printer. So Santosh has started using this printer. Now in the same time, what happens is Harish is going to use the absent printer and he's using the printer for printing. Now once Santosh has done with the HP printer, what he wants to use? He wants to use the absent printer, which is held by Harish. You will see the highlighted one. And once Harish has done this printer work from the absent printer, what he's going to use? He's going to use the HP printer, which is held by Santosh. Now nobody is leaving each other. Now you will see a deadlock situation happens here and this program will halt here and it will not come out ever. Now to see how whether deadlock has happened in our program or not, you can use the JVisualizer tool which is given by Oracle. So just open the file explorer, go to the program files where you have installed Java, and here the JDK will be there. Go to the bin and here you will see JVisualizer tool, jvisualvm.exe. Double click here. You will get the JVisualizer tool open. Go to the application and here you will see some Java programs running in your own local system. So which is our own Java program? This is thread deadlock example. Now just go here and double click this thread deadlock example. Go to the threads section and you will see here one deadlock detected will come. So whenever your application halts for a longer duration, you just suspect that there might be a deadlock happened. Now let's talk about how to resolve this deadlock detection or deadlock. situation. Let me just stop this program. So how to avoid the deadlock? You have to avoid the nested locks. In our case, we have the nested locks here. First, we have taken the printer 1 lock, and then inside this first lock itself, we are taking a lock on printer 2, which is lock inside one more lock, which is a nested locking. So you have to avoid this nested locking. Avoid unnecessary locks. So wherever you don't need any locks, you don't take that lock. Using thread.join. So this is the third way in which you can avoid the deadlock. So thread.join, what will happen is, let's say you first you say that printer user 1 dot start, and then you say that printer user 1 dot join. So what will happen is this printer user dot join will ensure that once Santosh has completed all the printing using both the printers, then only Harish can do the work or do the printing. This is how you can avoid the deadlock. I hope this is clear. You can find the example in my code base, which is given there in the video description. Thanks for watching this video and stay tuned.